So first part of section 9.2 is basically looking at a different way of graphing, and this is called polar. So on the calculator, there is a mode for polar. It's right next to parametric. But polar is a little bit different than the other types of graphing we've done. Parametric and function notation both use a grid that has an x and a y axis. Right? It doesn't matter what system you're using. You're still using an x-y axis. Polar is a different way to write your equation, but it also uses a different grid system. So it's more different than the other two. There's more things that are different. So up until now, even with parametric, we've been using a rectangular coordinate system. But in polar, certain curves are a lot easier to draw. Let me show you an example of how to draw a circle in all three systems. I'm going to do it as a function, and I kind of have to cheat and do the top and the bottom half separate. It's the only way to do it. But I'm going to do it as a function, then I'm going to do it parametrically, and then I'm going to do it in polar. So you can see all three ways to do it. And you tell me which one looks the easiest. All right, so let's start with a function. So to graph a circle as a function, you have to use the equation x squared plus y squared equals r squared. Okay, that's the equation of a circle.
In polar?
That's as a function.
As a function.
Yeah, polar, we'll do that. We went over some in the homework, but we'll do a circle in polar in a minute. That's just the r cosine and the r sine.
Okay.
That one's a little easier than this. But I think you'll find polar is the easiest of all. So here's the equation of a circle as a function. To put that in the calculator, I need to get y by itself. So it just means taking the square root of both sides. Now, x squared plus y squared, that should be r squared. Sorry. Now, I want to pick a radius. Let's do a circle of radius 3. So actually, no, to get y by itself, I need to move the x squared over. And then take the square root of both sides.
Do we know how to do this?
Yeah, you should know how to write the equation of a circle. Yeah. So, when you take a square root, how many answers do you get? 2. So let's type that in on the calculator. I'm going to have to use a y1 and a y2 because I have a positive and a negative. And I'm going to let r be 3 because I just want to do a circle of radius 3. So let's watch how much stuff I have to type in to make a circle. All right, so I'm going to go second square root 9 minus x squared. That's going to be the top half of the circle. And then the negative square root of 9 minus x squared. Again, I'm letting the radius be 3. All right, so let me do a zoom 5. Oh, you know what? Let me reset my calculator because I need to turn my axes back on. So reset. Actually, you know what? Maybe I can just reset the defaults. Let's see. All right, and I'll try to make it a little brighter again. There we go. All right, so let me type it in again. So square root of 9 minus x squared, and the negative square root of 9 minus x squared. All right, and do zoom 5. So there's a circle as a function. Right? And it doesn't even really connect because remember when you start to get vertical, the calculator has a hard time drawing things that are vertical, and the sides of the circle, well not sides, but the edges get pretty vertical. But that's the best I can do. Right? That's how you make a circle as a function. Now, the next way we learned was parametric. So in parametric, these are the two equations you take in. All right. So let's switch over to parametric, type the same thing in, and compare that. So let's go to parametric. Y equals, type in, I'm doing a radius of 3, so 3 cosine, whoop, that should be a t. You'll see today we're going to start using theta. But that's t, because it's parametric. So 3 cosine t and 3 sine t. All right, my window should be the same as what I did before. Hit graph. There you go. So that looks a little better than the last one. I don't have to draw 2 separate halves. And I think the equation is a little bit simpler. It uses trig, but at least you don't have to do like a y1 and a y2 separate. It's just one system of parametric equations. Now, let's look at polar. So I'm going to change the mode to polar, and we're going to do a lot more with polar graphing tomorrow, but for today, I'll just show you this one thing. And we're going to graph a circle of radius 3. And that's it. That's the whole thing. So to get a circle of radius 3, all I had to do was, I was trying to get it when the cursor wasn't blinking. There you go. That's it, that one number. So polar is really designed to be able to graph circles very, very easily. Let's see. Okay, parametric, not too bad. Functions, yeah, it's off. You can't even really do it. You have to kind of cheat and do the top and the bottom half separate. So polar, very easy for circles. What do you think would be pretty complicated in polar? That's actually simple somewhere else. Yeah?
Moving the origin.
So moving the origin can be a little tricky. We can do it though, but that is, think of another shape completely. Yeah? Lines. In polar, lines are very difficult or very complicated. In fact, to do a line in polar, you need to use trig. Compared to if you just use function notation, you just use your y equals mx plus b, and you're done. So function is very good for lines, polar is not. So each system kind of has its advantages and disadvantages. Today, we're going to look at polar, but we're going to focus mainly on single points. How do you graph a single point in polar? And how do you convert a point in polar to rectangular, and rectangular back to polar? These two systems are rectangular, function and parametric. They use xy axes. This system does not. Okay, polar uses a different system, and that's what I'm going to show you. So this is polar. Okay, so a polar basically looks like a set of circles, concentric circles, where the origin is called the pole, and this line is called the polar axis. And you'll see there really isn't a name for a vertical because there is no vertical axis here. Everything is measured as an angle from the polar axis. That's really the only axis you have. When you graph a point in polar, it still uses 2 values, but they're not an x and a y. The 2 values are an r and a theta. Oh. What do you think r stands for?
Radius.
Radius. And theta usually represents what?
Angle.
An angle. So r is a radius, or basically like a distance from the origin, and theta is an angle. Now there's really, besides having a 0 in for one of these values, there's really 4 cases you can have. You could have 2 positive values, 2 negative values, or 1 of each. So we just have to know, like x and y coordinates, what direction do you move if r is positive? Which way do you go if r is negative? What if theta is positive? So let's look at how you graph a point given the radius and the angle. So this isn't even an entire picture. This is just a single point. That's all we're doing. The first thing you do is you look at r. If r is a positive value, it's almost like if x is a positive value. You basically do the same thing. You move to the right. So if r is greater than 0, you're going to move to the right that many units. If r is less than 0, you're going to move to the left. Now, like an xy coordinate, that's not the final answer. You still have to take into account the second number. But that's the first move you do. You either move right if r is positive, or left if r is negative. Now, theta is an angle. Think about an angle. That's movement on a circle. When we talk about movement on a circle, it's not described as left, right, up, or down. What are the two ways you can describe circular movement? Yep.
So many degrees or
Okay, even simpler than that. Those are the two units we are going to use, but depending on if the degrees is positive or negative, you would move either this way or this way. Yep.
clockwise or counterclockwise.
Yep. So the angle tells you clockwise or counterclockwise movement, and the angle will always be degrees or radians. If the angle is positive, you're going to move counterclockwise. If the angle is negative, you move clockwise. And this is all movement after you do step 1. So first you move the number of units for the radius. Then you move clockwise or counterclockwise from there. All right, so now we'll just look at a few examples where we practice graphing points. And we'll look at the different cases, positives and negatives. All right, let's try graphing 345 degrees. Now, what I would do if you don't have polar graph paper, you could just Google polar graph paper and print one out. But if you just draw it one time like that, then you could put all your points for the homework that need graphing on the same grid. Just label, like, this is number 2 from the homework. This is number 3. Just label which one is which, and you could use the same grid. All right, so 345 degrees. John, what's my radius? 3? So I'm going to start out by going 3 units which way? Right. To the right, starting from, from the pole or from the origin. So 3 units right, 1, 2, 3. I'm going to put a temporary mark right there. That's not the answer, but that's where I'm going to start from now. 3 units right. And Caleb, how many degrees do I have to rotate?
45 degrees counterclockwise.
Yep, so I'm going to rotate 45 degrees in a counterclockwise direction. That puts me right there. So that's the point, 345 degrees. Questions on that? All right, let's try this one. Negative 275 degrees. Madison, what's my radius? Well, what direction am I going to move in here? Left. How many units? 2. So you're going to start from right there. And Sophie, what do I do from here? Counterclockwise 75 degrees. What quadrant is that going to land me in?
3.
Yeah, I'm still going to be in quadrant 3 because I'm not rotating 90. That would get me out of it. But I'm going to be rotating 75 degrees. So that puts me 15 degrees before the 270 mark, if you think of it that way. Any question on that one? All right, how about 3, negative 60? Maddie, what would I do first?
We'll write 3.
Okay, so we write 3. And Lindsay from there?
You're gonna go clockwise 60 degrees.
Yep, I'm going to go clockwise 60 degrees, and that's still going to keep me in quadrant 4, but it's going to move me 2/3 of the way through it. So I would go halfway, and just go a little bit more. Maybe a little more, like that. Questions on that? All right, let's try this one. -4, -3 pi over 2. It might help if you're not comfortable with the radians to switch it over to degrees. What would that be in degrees? Okay.
30.
How much?
30.
30, that would be pi over 6. That's, no, not 270. Yeah.
45 degrees.
45, that's pi over 4. Negatives, exactly. The only time the negative doesn't really matter is if it's 180, because whether you go halfway around clockwise or halfway around counterclockwise, that doesn't matter. But the negative matters here. Okay, Leanne, what's the first thing I would do?
I'll go left 4.
All right, so we're going to go left 4. 1, 2, 3, 4. And Mabel, how many degrees do I move?
You go clockwise 270.
Clockwise 270. Where's that going to put me?
Yeah, the. Yeah. The vertical axis on the bottom.
The vertical, yeah. The vertical axis on the bottom. Okay, so let me write it in degrees. -4, -270. And this time, let me draw how we got there. Left 4, and then we went around like this. What's another way to get to that point? Another coordinate. So if we did -4, that would bring me left 4, and then 90 would bring me that one. Yep.
What would you do? Positive. -90.
So +4, -90. 1, 2, 3, 4.
So you go the other way.
-90. One more.
+4, 270.
+4, 270. So, there are 4 basic ways to get to every point in polar. Put your positive, positive, negative, negative, and then one of each. Positive and a negative, or negative and a positive. Now, going around more than one time doesn't count as a different way. Like, if you went right, and then went around, and then around and stopped, that's not a different way. Okay, the choices are either left and right, and then clockwise or counterclockwise. And this covers all those choices. Yep.
Are you going to have colored graph paper for us on the test?
Yeah.
Okay.
Yep. So, if you think about Cartesian coordinates, how many ways are there to get to a single point? Like, let's say I want to get to this point right there. How many ways can you write that coordinate? Just one. There is only one way to write it. But in polar, there can be up to 4. I shouldn't say there's always 4 because it depends if you start on an axis, there might only be 3. Depending, like if you started over here or over here. But yeah, it can be up to 4 ways to get to a point in polar. Questions on that idea? So which way is preferred? I don't know. The positive usually is pretty popular. So it just depends on what they ask for. All right, let's try this one. Okay, 0 pi. What's going to happen here?
It's just at the origin.
It's going to stay at the origin. So your point is at the origin, but what you have to do is then rotate it 180, like that.
How do we show that?
Well, the way I used to be able to tell on a test when I did it on like paper is I could tell if you put your pencil down and you spun it, because I could see the swirl mark in the graphic. You know what I mean?
Yeah.
You could see it. Really, you could. I mean, that's what I graded it
like
on.
a mechanical.
Yeah. Well, then I'd have to magnify it, but I could still see
Oh my goodness.
the swirl. Even with a pen, you can see the swirl a little bit.
I'm just gonna show an arrow.
Okay. So that's 0 pi, right? Stays at the origin. 0 comma anything is always right at the origin. How about something comma 0? Will that be at the origin?
No. It would just be on an axis.
Yeah, this is going to be on the polar axis when you do something comma 0. So this one would be right there. Right. So any questions on the graph? That's basically one of every type. You want to see a second one of every
No.
type?
No.
Okay. That's kind of the same thing.
Yep.
So I already explained this to you. There's more than one way, up to 4, usually a minimum of 3. Everybody comfortable with figuring out different ways to write a point in polar? I think the easiest way is if you sketch it. You could try to come up with formulas like, okay, if I make the radius negative, then I could add 180 to the angle. I don't really think of it as formulas. I just graph it, and then I look at it, and I figure out the different ways that way. All right, so converting from polar to rectangular. When you have a point in polar, what are the two things that they give you?
Radius.
The radius and the angle. And when you have a point on a rectangular coordinate system, what do they want you to have? They want you to have an x and a y. So we have to convert between r and theta and get that to be an x and a y. So let's pretend like we have a point in polar. Right? That point has a certain radius from the origin. Okay, that's my radius. And it has a certain angle of rotation to get to that point. That's the angle that I rotated. Now we've done this kind of thing quite a bit for different topics. How do you think I can convert this into an x and a y? Yeah?
You make a triangle.
Okay.
You find out the other end. Yep.
Okay.
And then you just put the numbers there.
You just put some numbers in there. Like that?
Yep.
Yep.
And do trigonometric stuff.
Do trigonometric stuff. All right. Maybe you were probably thinking of making a triangle in quadrant 1, right?
No, you did it right.
I did it right? Okay. Well, let me do it. Let me try it this way. Just for fun of it.
If you want to.
So we've got a triangle. And this is 90. Now, what is this?
The horizontal.
Radius. No.
Well, it wouldn't be the radius, but it would be,
The horizontal.
right. This is the horizontal distance you move from the origin to get lined up vertically with the point. So it moves you over a certain amount, left or right. Now, what about this? Yeah, that's the y.
Oh, you see Pythagorean Theorem. Right, Nick?
That's the vertical distance you move to get from there up to there. So what would be the formula for the x value? John? cosine theta. And what would be the formula for the y value?
R sine theta.
R sine theta. So it looks kind of like a set of parametric equations. It basically is. But it gives you a way to take a radius and an angle, and it turns those two things into an x value and a y value, which is what you need when you write something in rectangular. And that's it. Those are your 2 points. Right, so that's how you convert from polar to rectangular. So let's try this one. You know what? Let's do this one first. We'll do this as example 8, and then I'll do the one above it as example 9. All right. What's going to be the formula for my x value? Nick?
3 cosine 5 pi over 6.
5 pi over 6. And the formula for my y value? Yep.
3 sine 5 pi over 6.
Yep, and it's perfectly fine to use 5 pi over 6. I just want to make sure of what on my calculator.
Radians.
Radians. So I'm already in radians. Now, what I would do is, forget about the 3 for a second. Let's just do the cosine of 5 pi over 6. Because pi over 6 is 30. So 5 pi over 6 is 150. Since this is a multiple of 30, they're probably going to write the answer with like a square root 3 or a square root 2, depending if it's a 0.866 or a 0.707. All right. And it's easier to see that if you don't triple it first. So just take the cosine of 5 pi over 6. Negative 0.866. What is negative 0.866 as an exact
Square root
fraction?
2 over 2.
That's 0.707.
Square root 3 over 2. 1/2.
And then 1/2. What's 1/2 as a decimal? 0.5, right. So that's not 0.5.
Square root 2 over 2.
That's 0.707.
Oh,
Is it
no, square root 2 over square root 2.
3 over 2.
Square root 3 over 2.
Oh.
So this is
Definitely not 0.5.
with a negative. So this is negative square root 3 over 2 times 3.
No one else thinks.
So the exact answer for that is negative 3 square root 3 over 2. If you had tripled it first, you probably wouldn't have recognized the decimal. So that's why I don't triple it first. Now, if one of them comes out as a root, the other one will come out nice. So the sine of 5 pi over 6.
This is 0.5.
1/2.
Yep, 1/2. And then half of 3.
Yeah.
Oops. Yeah, that's 1/2. That's times 3. 1/2 times 3 is 1.5. Now, just write your coordinate. So the x value, negative 3 root 3 over 2. And the y value, I guess if you want to keep it as a fraction like everything else, you could do it like that. 3/2. And that's it. So the two special numbers that are going to come up when you do a point like this, root 3 over 2 and root 2 over 2. But that's only if you have an angle that's a multiple of 30 or 45. Is negative 200 a multiple of either one of those numbers? No. So this time, we'll just do it and we'll round it to 2 decimal places. So on the test, you might have one that's an exact answer problem like we did, and then you might have one that's a decimal. Okay, I'm not going to write it. I'll just type it. What do I type in for the x formula?
2 cosine.
Negative 200.
Put in degrees mode.
Yep. I can still put it in degrees mode after I type it. I just need to do it before I hit enter. All right, so put it in degrees. And hit enter. And you get negative 1.88. And the y value?
You would just copy it and change it to something.
What is it?
You can like copy it and change it
It's
to
kind of
something.
poor. I can't afford.
Yeah, copy it and then change it to time. Whether you copy it and change it or just retype it, I can probably type it just as fast. I don't know which way is quicker. We get 0.68. Any question on that? Let's graph that point. Okay, 2, negative 200. This is like my favorite thing all year. Okay, so just enjoy this. Let's take, I need a polar background. And I need a certain size. I think that's the one I want. But what was the point? 2, negative 200. I want to try to be as exact as I can. So write 2, and then negative 200. Well, that's going to bring me around clockwise. How far is halfway?
180.
180. And then each one of these lines is 15. So if I go one line, what am I at now?
195.
195. And I want to go a little bit more. So that's about negative 200. Okay. Question on that? Okay. Now, what was the point? Negative 1.88, 0.68. If I change the background and leave that point exactly where it is, and I change it to a rectangular grid, that point should look like it's almost 2 units over to the left and a little bit more than half a unit up. Right? So let's see. Take this, change the background. Huh? Yeah, right? Look at it. Negative 1.88, so a little bit before 2, and 0.68, a little bit more than halfway up. Isn't that mind-blowing? Isn't that cool? Okay. It's just amazing. You can do that all day. It's great, you know? So I'm just showing you that what we did to convert it, it matches up. The key to making that work is you have to use the same spaced graph paper, and the polar graph paper is exactly the same size as this grid. That's why it worked. All right, so that's converting from polar to rectangular. Now, let's look at converting rectangular to polar. I think that's, yeah. Okay, so rectangular. What are they going to give me this time? X and a Y. And what are they going to want in polar? An R and a theta. So now we got to reverse it. We got to somehow get an R and a theta from the X and the Y. So I've drawn the same type of diagram, except this time you're going to know the X and the Y. So how can you find the R?
Pythagorean.
Yep.
Good boy today.
We can use the Pythagorean Theorem. And I'm going to write this down in a second. But we can use Pythagorean Theorem to find R. Now, how would you find the angle if you know those two?
Tangent.
Yeah, you have to use the tangent. Again, I'm going to write this nicely in a second. But tangent of theta equals what would go on the other side? Y over x. And that's technically not theta, that's tan theta. So what would you do?
The inverse tangent.
Yep, take the inverse tangent. All right, so let's write that down nicely so we have some steps. My first suggestion is to graph the point and figure out the quadrant. Because when we studied inverse tangent, does anyone remember what two numbers the inverse tangent was always between?
Negative 1 and 1.
1.
So it does go up and down forever, but that's the range. I'm thinking of,
Negative pi over 2, pi over 2.
yeah, the domain was negative pi over 2, or yeah, it always gave us an answer between negative pi over 2 and pi over 2. That's what we limited the domain of tangent to. So you're right. So yeah, technically, I should say that. The domain was limited to -90 to +90. We did that in order to make it a function because it looked like this. And we wanted to find one section that passed the vertical line test. And this is the section that we picked. The section between -90 and 90, or -π/2 and π/2. So the problem is when you do inverse tangent, the angle is always going to be between -90 and 90. Well, this is -90, and this is +90. What quadrant would you always be in, or quadrants, if your answer is between -90 and +90? You'd always be in 1 or 4. Inverse tangent by itself will never give you an answer in quadrants 2 and 3. Well, that's a problem because you could have a coordinate like -2, 5, and you have to convert that to polar. So what do you do if you have a problem in quadrants 2 or 3? Oh, I'll show you. If you're in quadrants 1 and 4, the inverse tangent works fine. You can just do inverse tangent because you will get an answer in quadrants 1 and 4. If you want to get an answer in quadrants 2 or 3, you have to add 180. That's how you get in quadrants 2 and 3. You take what you get from the inverse tangent, and then you add 180. You only have to add 180 if you are finding an answer in quadrants 2 or 3. Or if you're doing it in radians, you would add pi. Now, these two formulas cover how to find your angle when you go from rectangular to polar if you're in quadrants 1, 2, 3, or 4. Where else could you be besides quadrants 1, 2, 3, 4? Yeah? You could be on the axis. Let's say you had a point right here. Can you tell me what the coordinate, or tell me as much as you can about that coordinate?
90 degrees.
0, y.
Yeah, it has a 0 for the x value, and I don't know how high up it is. It's y. But it has 0 for the x. What's wrong with plugging a 0 in for x in those formulas? You'd be dividing by 0. So these formulas don't work if you're on an axis. How do you figure it out if you're on an axis? You just have to memorize it. Okay. This is 0. If you go up, it's 90. Left is 180. Down is 270. You just have to memorize those 4. So now, between knowing the 4 that are on an axis and knowing the formulas for your quadrants, you can find an angle in polar, no matter what the coordinate they give you is. And once you have your angle, or you could do this first if you want, it doesn't matter. You also need the radius, and that's just Pythagorean Theorem. X squared plus y squared equals r squared. All right, so let's try an example of converting to polar. And that's it. Everybody have the formula? Yep. Oh. All right. Do you want to do the one? Well, that's an easy one because it's on an axis. We'll do that after. Let's do this one because it's not on an axis, so you actually have to think about and figure out the angle. You can't just quickly get the angle. All right. What quadrant is this in? Let's just do a quick sketch.
4.
3, -5. 3, -5. Somewhere around there, that's quadrant 4. What's my formula to find theta in that quadrant?
Inverse tangent. -5.
What about plus 180?
No.
Nope, not in quadrant 4. Inverse tangent of, what did you say? -5 divided by 2. All right, let's do it again. So the angle, and I'm in degrees, so that's whatever mode they want you to be in. -59.04. Now, we've talked about polar, and I showed you guys there's 4 different ways to write a coordinate in polar. What if they didn't want that as a negative angle? How could you make it positive? You could just add 1 revolution to it. They didn't say to do that here. I'm just showing it to you, and we've already done that earlier today. 300.96. I'm going to write the answer with the positive one. There's nothing wrong with the negative one. If they say you can use a negative, then use it. Okay, so there's my angle. How do I get my radius?
5 times 5 plus 2 times 3
Yeah,
square root.
this is 3. This is 5. So radius equals, what's 3 squared?
25. 9.
And 5 squared?
30.
So what is my radius?
Square root of 34.
Yeah, and if you rounded the angle off, I mean, you probably should round the radius off too, but we could leave it exact, I guess. That's fine. So the coordinate is r, comma, theta. And remember, there's 4 ways to write that coordinate. Another way would be square root 34, negative 59.04. Question on that one? All right. And this one. What's my radius? 6. Okay, all I've done is go 6 units. Well, 6 units which way? Up. So because that's a 0, you can just count 6 up. And what's your angle if you go up? 90. That's why that one's a lot easier. So your answer is 6, comma 90. And again, there'd be 3 other ways you could write that one if you wanted. Questions on that? All right. So that's the homework for tonight. Page 492, and it's 1 through 16.